The dawn of flight, from dreams to piston engines. For millennia, humans gazed at the birds soaring above, longing to touch the heavens. Dreams of flight filled countless stories and myths. Then came the Wright brothers. In 1903, their Wright Flyer, powered by a rudimentary piston engine, made history. This marked the beginning of our journey into the sky. Early airplane engines, like those in the Wright Flyer, were essentially modified car engines. They used pistons, cylinders, and propellers to generate thrust. These engines were heavy and not very powerful, but they proved that powered flight was possible. Over time, these piston engines became more sophisticated. Engineers developed lighter materials and more efficient designs. Airplanes could fly higher, faster, and farther, yet the dream of breaking free from the limitations of propellers lingered. A new era was about to dawn. Beyond propellers, the rise of the jet age. The quest for greater speed and altitude led to the development of jet engines. Unlike piston engines, jet engines don't use propellers. Instead, they harness the power of hot, expanding gases to create thrust. This revolutionary technology transformed aviation. The first jet engine, built in the 1930s, marked a turning point in flight history. It promised a future of faster and more powerful aircraft. The jet engine's basic principle is elegantly simple yet remarkably powerful. It's based on Newton's third law of motion. For every action, there is an equal and opposite reaction. Imagine a balloon filled with air. When you release the balloon's opening, the air rushes out, propelling the balloon forward. A jet engine operates on a similar principle, but on a much larger and more controlled scale. Let's delve into the heart of this remarkable machine. The heart of the machine: understanding jet propulsion. Jet propulsion relies on a continuous cycle of 4 key stages: intake, compression, combustion, and exhaust. Each stage plays a critical role in generating the powerful thrust that propels an aircraft through the sky. The cycle begins with intake. As the airplane moves forward, air is drawn into the engine. This incoming air is crucial for the entire process. It contains the oxygen needed for combustion, the process that ultimately powers the engine. The next stage, compression, is where the magic begins. The incoming air is forced into a smaller and smaller space. This compression increases the air's pressure and temperature, setting the stage for the next crucial step: combustion. Intake, swallowing the skies. The journey of air through a jet engine starts at the intake. This carefully designed opening at the front of the engine acts like a giant mouth, gulping down vast quantities of air as the aircraft slices through the sky. The shape of the intake is crucial. It's designed to smoothly funnel air into the engine, minimizing turbulence and maximizing efficiency. Think of it like the aerodynamic design of a sports car, guiding the flow of air to reduce drag. As the airplane gains speed, the intake swallows more and more air. This continuous supply of air is the lifeblood of the jet engine, providing the essential ingredient for the combustion that will unleash tremendous power. Section 5. Compression, preparing for ignition. Once inside the engine, the air doesn't just flow straight through. It encounters a series of fan blades attached to a rotating shaft. These blades compress the air, squeezing it into a smaller and smaller space. This compression is key to the jet engine's efficiency. Imagine squeezing a sponge. As you compress it, the air inside is forced into a smaller volume. The same principle applies in a jet engine. The compressed air becomes hotter and denser, primed for the controlled explosion that will propel the aircraft forward. This compression stage is a marvel of engineering. The fan blades are incredibly strong and precisely engineered to withstand immense forces as they spin at high speeds, compressing vast quantities of air thousands of times per minute. Section 6. Combustion, unleashing the power. With the air compressed and heated, it's ready for the heart of the jet engine, the combustion chamber. Here, the compressed air is mixed with fuel and ignited. This controlled explosion releases a tremendous amount of energy, heating the air to extremely high temperatures. Think of it like lighting a firecracker, but on a much larger and more controlled scale. The combustion chamber is designed to withstand the intense heat and pressure generated by the continuous explosions. It's a testament to the ingenuity of engineers. This superheated, expanding gas needs somewhere to go. It rushes towards the back of the engine, passing through a set of turbines, which we'll explore in the next section. Section 7, exhaust thrusting forward. The final stage of the jet propulsion cycle is the exhaust. The hot, expanding gases, now carrying tremendous energy, are forced out of the back of the engine through a narrow nozzle. This high-velocity exhaust creates thrust, propelling the aircraft forward. Remember Newton's third law? The force of the gases rushing out the back of the engine creates an equal and opposite force pushing the aircraft forward. It's this simple yet powerful principle that enables jet-powered flight. The shape of the exhaust nozzle is crucial for maximizing thrust. It's designed to accelerate the exhaust gases to their highest possible velocity, squeezing every bit of thrust from the engine. Section 8, the turbine, a symphony of power. Before the hot gases exit the engine, they encounter one more crucial component, the turbine. This spinning wheel of blades sits in the path of the expanding gases. As the gases rush past, they push on the turbine blades, causing it to spin rapidly. Think of a windmill, its blades turning in the wind. The turbine in a jet engine works similarly, but instead of wind, it's driven by the powerful force of the expanding gases. This spinning turbine is connected to a shaft that runs the length of the engine. This shaft powers the compressor at the front of the engine, drawing in more air and perpetuating the cycle of intake, compression, combustion, and exhaust. Section 9, turbofan versus turbojet, a tale of two engines. While all jet engines operate on the same fundamental principles, there are variations in design. Two common types are the turbofan and the turbojet. They differ primarily in how they utilize the exhaust gases. Turbojet engines are the simpler of the two. They direct most of the exhaust gases out the back to generate thrust. These engines are efficient at high speeds, making them suitable for supersonic aircraft. Turbofan engines, on the other hand, use a portion of the exhaust gases to power a large fan at the front of the engine. This fan bypasses the core of the engine, drawing in additional air and providing extra thrust. Turbofans are more fuel efficient at lower speeds, making them ideal for commercial airliners. Section 10. Innovations on the horizon, the future of flight. The evolution of jet engines continues. Engineers are constantly seeking ways to improve efficiency, reduce emissions, and increase performance. New materials, advanced designs, and innovative technologies are shaping the future of flight. One area of focus is reducing noise. Modern jet engines are significantly quieter than their predecessors thanks to innovative designs that muffle the roar of the exhaust. But the quest for even quieter engines continues. Another area of innovation is fuel efficiency. With growing concerns about climate change, airlines are eager to reduce their carbon footprint. Engine manufacturers are developing new technologies such as biofuels and hybrid electric propulsion systems to make air travel more sustainable. Section 11. A marvel of engineering. The enduring legacy of airplane engines. From the early piston engines of the Wright brothers to the sophisticated turbofans powering modern airliners, the evolution of airplane engines is a testament to human ingenuity. These marvels of engineering have shrunk our world, connecting people and cultures across vast distances. The next time you board an airplane, take a moment to appreciate the incredible technology that makes it all possible. As you soar through the sky, remember the countless hours of research, design, and testing that went into creating these powerful yet elegant machines. The roar of the engines, once a symbol of our ambition to conquer the skies, is now a familiar soundtrack to our interconnected world. As technology continues to advance, one can only imagine what the future holds for the evolution of flight.